Real polynomials. A polynomial is an expression of the form p of x is equal to a0 plus a1x plus a2x squared, and so on, up to an x to the n, which is a general term, and it may go on forever. All of the various a's, that's the a0, the a1, the a2, and so on, are coefficients. In other words, they're just numbers. If we have f of x is 3 plus 5x, that's a polynomial with a0 is equal to 3 and a1 equal to 5. So a0 is 3, a1 is 5, and all of the other coefficients are 0. So we really just end up with the first two terms. G of x is 7 take away 4x plus 2x squared is a polynomial with a0 is 7, a1 is negative 4, and a2 is equal to 2. And all of the other coefficients are 0. In fact, numbers themselves are polynomials. If we have h of x is equal to 9, that's a polynomial with a0 is equal to 9 and all of the other coefficients being equal to 0. So numbers are just polynomials. The degree of a polynomial is the power on the highest powered non-zero term. So if f of x is 3 plus 5x minus 2x cubed, we can see the highest powered term here is the cube. That's a polynomial, therefore, of degree 3. G of x is 2 minus 5x squared minus 2x cubed plus 4x to the 6. The highest powered non-zero term is the x to the 6, so that's a polynomial of degree 6. P of x is negative 3, so the constant term is the highest non-zero. And remember, that would be negative 3x to the 0. It's just that we know x to the 0 is 1. So that's a polynomial of degree 0. So numbers are polynomials of degree 0. And then we have q of x, which is 6 minus 4x. The highest non-zero term is an x to the power 1. So that's a polynomial of degree 1. If we consider f of x is the square root of x, that's not a polynomial because the square root of x is x to the power 1/2. And polynomials only have powers that are positive whole numbers or 0. So all of the natural numbers and 0 are the powers on a polynomial. For the same reason, then, this g of x can't be a polynomial. It's fine with the x cubed, x squared, x and 1, but when you get this 1 over x, of course, that's x to the negative 1. So 1 over x is x to the negative 1, and of course that's not a positive whole number as the power here. Consider once again the polynomial p of x is a0 plus a1x plus a2x squared and so on. If an is the last non-zero a in the list, i.e. the non-zero attached to the highest power, it's known as the leading coefficient. In this case, n is the degree of the polynomial. a0 is known as the constant term, and that's because it doesn't have an x, or at least it has an x to the power 0, which we know is just 1. So it doesn't matter what x is, a0 will always have the same value. X is known as the variable. So if all of the a's are real numbers, and that's all of the a's from a0 up to an, if we're considering this one to be the last non-zero, then the polynomial is a real polynomial. So a real polynomial is a polynomial where all of the coefficients are real numbers.